Hello everyone, this side Kartik Bhaiya from Coding Blog. So today I have a very special guest with us. Her name is Jocelyn and she is a PhD from Purdue University and she currently works at NASA. So yeah, you heard that right. It's NASA. That's a place for millions of people dream to go and work at. So welcome aboard, Jocelyn. You are a true inspiration for the students and millions of people. So you can also tell us the students about yourself.
Yeah, hello everyone. I'm calling in from Houston, Texas. I work at Johnson Space Center. There's lots of NASA centers all over the United States, and this one's in Texas. And we focus primarily on the astronauts and training them and getting them to space and back safely. And so, yeah, it's a great place to be, and I'm looking forward to talking with you more about this.
So yeah, that's the most important thing to take the guys back the with full safety. So yeah, Jocelyn, I would like to ask that. Okay, so was NASA your dream place to work, or did it just happen by chance?
Yes, so I grew up in Florida where there's a different NASA center, Kennedy Space Center, and
Okay.
that's actually the place where the space shuttle used to launch. So when I was a young kid, I could actually see the space shuttles launching occasionally. And then even, it would be a few hours drive and we could go closer to watch them. And so it was really impactful to my childhood to be surrounded by, this engineering feat. And it was just so amazing to me. And I actually at that time kind of thought I would want to do engineering. And naturally, because I was surrounded by that, I'll do aerospace engineering, because I really liked watching the launches and thought it was really cool. So that's how my journey started out, was just kind of, I want to do engineering, aerospace engineering, and probably I'll work at Kennedy Space Center, was like in my mind. But then later on, as I kept studying, once I went to Embry-Riddle Aeronautical University, actually even in just my first year of classes, I started to learn about all the things that happen to the human body when they go to space. And so that just opened my eyes to another part of this whole, so it's not just the vehicle that they're flying in, but also the medical side. And so that's what encouraged me to keep studying and go to graduate school so that I could learn more about biomedical side and space life sciences. And then that brought me over to Johnson Space Center in Texas rather than Kennedy. So a bit of luck, a bit of planning, somewhere in between.
So that's great. We don't actually get to see that particular thing a lot in India. So you were quite lucky that you have that space shuttle near where you actually stay. That must have been really exciting. Like that's super cool. So
Yeah,
yeah.
yeah, it was really cool. I would say it's not even just seeing it, it's like feeling it, because the whole ground is just shaking because it's so strong.
Okay. That is really great, really great. So, okay, so the next question that I would like to ask is that many of us would like to ask is that how did you start the preparation for it? Like, yeah, you have seen that there are space shuttles that are going up into the space, and yeah, but there is something where we start. We actually know, okay, this is how our journey should start. This is how I should start preparing for this particular journey. So, what was it like? How did you start that particular thing?
Right. Well, I think it honestly started with some really good teachers growing up,
Okay.
especially in my math classes. So that encouraged me a lot to study engineering because I loved math so much. So that was all because of my teacher, because she really made it fun. And because of that, I loved math. And because I loved math, I thought, okay, I can be an engineer. So it starts somewhere with planting a small seed, having an inspiration moment, or just something you like to do, and finding how it can fit in with industry and technology. And so that's why outreach events like what you're doing are so important. and especially even for young kids, like bring, new ideas, things they've never been exposed to, just to put that in front of them, and all different things. And one or two will really like spark their imagination.
Yeah.
So I think just exposure to new things and seeing what you like, and then starting there and growing.
Okay. So yeah, I think that is very important to get a good teacher. If you are going to start with a particular thing, you actually don't know what you need to study in that particular field or in that particular subject. A teacher actually gives you a path. The learning, I guess, is the hard work that you put into that particular thing. So I think yeah, teacher is actually. So is there someone that you would like to mention that okay, this was this particular teacher, because many would be excited to know about who was that particular teacher who started your journey over there. Yeah.
Yeah, I mean, I think there's a series of people in my life who have inspired me and helped me see like new paths, like you said, like how to get there. So the math teacher, her name is Mrs. Campbell,
Okay.
and she was so amazing. Like she really like poured her passion into her teaching, and she even like gave us the opportunity to take some university classes while we were still in high school. So as a teenager, she was finishing her master's so that she could teach some. As a teenager, we could take college classes because she finished her master's, so she could teach us some college classes too when we were even just a teenager. So that was amazing. And then when I got to university, I mentioned how I got inspired about the medicine side with aerospace. So that was Dr. Esther Beltran, and she came to one of our classes as a guest speaker, and it was just explaining to us to her simple stuff, the things she did every day in her job. But it was so amazing to us to hear about taking care of astronauts and all the things that happen to their bodies. So she really inspired me. And then in graduate school, you get advisors too. So for my master's, I had Dr. Eric Nauman as an advisor, and he's an amazing engineer. He does mechanical engineering and also biomedical engineering. So he uses his very deep knowledge of mechanical engineering, and then addresses more physiological problems and medical treatments. So he was amazing. And then, and Ph.D., I studied with first Dr. Omid Nohadani, and he taught me a lot of optimization techniques and data analysis and kind of programming. And then when I did my dissertation, I worked under Dr. Steve Landry, another great person to work with. He's your PhD is a time that can be very stressful. You have a lot of work and everything, but he's just very relaxed and, lets you have some freedom and encourages your ideas. So he's another great mentor along the way.
So that is great. So a series of mentors actually help you guided that, and that was quite amazing. Like you are in high school and you are attending the college classes. I don't think it's possible in India that you are allowed to do so.
Oh wow, yeah, it was really good because then when you start engineering, usually you would start with calculus and physics at the same time, which can be really hard because you kind of need calculus to understand physics. So by having a little bit of calculus already, it I think really helped me succeed and make my first year a little easier.
So actually, the calculus is taught to Indian students in their high school itself. Like we have those particular thing as subjects as well. So many of the students are kind of scared with mathematics. So I would also like to tell that I also happened to come across a teacher, and he was really great. His name is Harish Kharbanda. I don't think many of students would know about him, but yeah, he was actually very great, and he helped me in building the interest in physics and mathematics. So I was also quite good with those particular subjects due to him only. Yeah. Okay, so many of the students, those who are actually pursuing BTech or engineering, they would want to know like what are the different options or fields available in NASA that they can go for or that they can explore into. So could you just show them some light on this particular thing, like what are the fields?
Absolutely. So working for NASA, for me, I'm on the space life sciences, so I can tell you a little bit about that part. But there's so many other areas, especially when you think about going to Mars. It requires everything, not just keeping a human healthy, but also you have to reuse all your resources. It's more sustainable energy and renewable solutions. So it can be everything from you know, water purification to growing plants to, reusing different, waste products and turning it into energy somehow. There's lots of other technologies that, it could be exciting to pursue on Earth too, like different sanitation systems and everything. But as soon as you say, I'm designing it for Mars, then it could be a little more interesting.
Okay, yeah,
So
yeah,
I
for
think it's
sure.
been that literally like every industry, I think you can find an application in space for the most part. There's some connections there. But the part that I work in is more life sciences. And so we have a physiology and performance laboratory where we focus on when the crew member is in a spacesuit. So
Okay.
they're in this confined suit that has to provide their oxygen and process all of their heat and the CO2 that they're breathing out, the carbon dioxide, because it can get toxic if it builds up. So you have these cooling capabilities and fans for bringing in new air and everything. And so we study basically like how to make this whole system more efficient and how to optimize the performance within an engineering solution of the spacesuit. You have certain limitations. So how can we design our operations to make the most efficient operations and safe operations too?
So, like just a random question: have you ever wear a space suit like yourself, or is it just for the astronaut? The person who will go into the space, it's just for them, or is there like anyone can go to NASA and they can ask like, I want to experience what it is like to be in the space? Is it possible?
So I'm on the list, but I haven't made it into the suit just
Okay.
yet.
Okay.
I've been in some more like mock-up spacesuits, so they're not the real ones. They're not like pressurized. But for some of our upcoming studies and engineering evaluations, they need just like test subjects. So I'm on the list to be a test subject, so I can be part of the evaluations and for the first time experience what it is like, because it should help my work to feel firsthand experience, because the joints all move differently. It's not like you can just raise your arm. You kind of
Okay.
have to like almost robotic, just move into the ways that the joints work. So I need to experience that and understand the fatigue from working. So basically, like you can think of it as being inside a balloon, right? Like you have this added pressure around you, and you have to like do lots of tasks, geology and things in your hands, fine motor. And so over time, I think your wrists, forearms, hands will get very exhausted from going against that all the
Okay.
time, that pressure of the suit. So I'm gonna experience that hopefully this year, maybe.
Okay, that's great. I hope that you experience that soon. So, like many people are actually working, like we want to go to Mars and establish a colony over there, or any involvement of NASA. Like I don't know whether this information is confidential or not. Is there like any possibility that NASA is also trying, or is it even possible for humans to be like on Mars in near future?
Yeah, so NASA does publish a lot of their plans publicly, so I can share that the number one priority right now is to go back to the moon. So that's where we will test habitat systems, use these new spacesuits, design next generation suits for Mars as well.
Okay.
So we need to go back to the moon first, because it hasn't been since the 70s. So we have a lot of new technology for rovers and communication and all of the tools and everything. So we have to start there. Did you know it takes actually like more like 6 to 9 months to get to Mars?
Okay.
So that's a long time to go and then practice, something that you've never really tested in space before. So we can get to the moon, and be more cost effective about testing our solutions. So the goals are around like 2025, 2026 to have the next people on the moon, and it'll actually be the first woman as well. They have specified to have the first woman and the next man to return to the moon. And then after that, maybe Mars will be in the 2030s, but it's more blurry, the timeline. But NASA is different from some of the other commercial initiatives, because for NASA, mission success is getting the people there and home safely. So some other commercial, options are maybe one-way ticket to Mars, or that's a little bit different, because NASA wants to have a complete safe mission. Safety always first.
So that's kind of scary. You can go there, but we won't take any responsibility for your return back to home. That's kind of scary. Okay. Next thing that probably many of the students would like to know is like, how is your day at NASA like? We as normal people, we work from 9 to 5 job, or somewhat like that only. So how is your day at NASA like, and what is it to work at NASA feels like?
Yeah. So working at NASA, I guess all of us are working from home this year anyway, but we are able to do some really exciting stuff. We still have, meetings and email and all of that dominating a lot of our schedules, but at least a couple times a month, I would say there's something really exciting going on in the lab, where that's, I can show some pictures and everything too, but that's where we will do some testing of EVA, or exploration outside the habitat, right? So EVA is anytime you put on the spacesuit.
Okay.
And so you can simulate being in partial gravity at a place called Argos, which stands for Active Response Gravity Offload System.
Okay.
So offloading your weight partially so that you can feel like you're on the moon or Mars. So it's like a robotic crane that will follow you around while you're walking in the suit. And so we'll do some testing like that of the spacesuit, and other places are where the astronauts actually train. So one is the Neutral Buoyancy Lab, and this is training for current, Earth orbit mission. So you're in full microgravity weightlessness, and so the best we can do to mimic that on Earth is actually going underwater, and then adding some flotation and weights to make this perfect balance where you're neutrally buoyant. In other words, you're not floating up and you're not sinking down. You're just at this equilibrium point. And so that's where astronauts train now. And we do different data collections there, looking at their physical workload and kind of consumables usage, so that we can understand for an upcoming spacewalk or EVA, how long will they be able to stay in this suit before they start to run out of oxygen, or most likely the limiting consumable is carbon dioxide removal, is ending up being the thing that runs out first usually. So we're always looking at how much CO2 is the person breathing out while doing different activities, and then optimizing to figure out then, which timeline of tasks can be completed realistically with the capacity that you have in the spacesuit.
Oh, okay. So, what about your day? Like, what do you actually do? If you could just show some of the students, like, what is it, and you could just share some images of your workstation and the place where you work at.
So, here's a roadmap that we have published, where You can find it at this link and read about a lot of our projects and work. And in this roadmap, actually, it's organized by some gaps of knowledge or technology, things that we're working on. So it can range from, looking at suit design, spacesuit design, how it fits the person, how to improve that, or even things like informatics. So that's like bioinformatics and feedback systems to help with decision making in real time, both for the person in the suit or also people on the ground who are assisting with the operations, having better software and sensors, data coming through to inform their decision making. So happy to share that with everyone. And so some fun pictures and everything we'll get to in a minute, but I'll just give a little background of EVAs. So for EVAs, we like to think about it as your physical work and your cognitive work, because it's kind of like exercise, because you have a lot of tasks in a pressurized spacesuit. And the spacesuit has certain limitations on its cooling capability, so you could run into some overheating if you work too hard and fast. So there's a balance there. And also you need to be able to not be working too hard that you're not able to make decisions and look closely at the work that you're doing, because we're in a very high risk environment. So keeping the balance of both your pace of work and your, optimizing what you're doing and your communication is really important for us.
Yeah, that. So,
Yep.
is there any difference? Is there any changes that human body would feel? Like, if I'm in a gravity, if I'll suddenly go to the environment where there's no gravity. So, what are the changes that comes to a particular human body?
So there's lots of changes in almost every area you can think of physiology. But the first transition will be once you get to microgravity, you actually will maybe have some motion sickness,
Okay.
because your inner ear and your balance system is very confused when there's not gravity anymore.
Okay.
So that's one thing that will happen, and tends to adapt fairly quickly in the order of a day or something, and they will get their space legs and start feeling okay. But also all your blood and fluids in your body will start to stay in your upper body because you don't have gravity pulling it down.
Oh, okay.
Your heart is located more higher up. So it's called a headward fluid shift. So you will have a puffy face,
Okay.
skinny legs,
Okay.
and microgravity. And it sounds funny, but it actually can cause some health problems. So in particular, the blood vessels and vasculature in the back of your eye is pretty sensitive to pressure changes. And so that's an ongoing area of research study. If you're in space for longer and longer, some of the things that they're seeing happen to the eyesight, what will happen to their vision long term, and do the tissues heal back and everything like that. So that's one area. And then of course, without gravity, everything is weightless, so your bone and muscles are not getting exercised as much, because even just standing right here, I'm having to keep my posture. Every time I raise my hand, I'm working against gravity. In space, there's nothing constantly like that, so they have to use resistance bands and aerobic exercise and work out 2 hours a day just to try to maintain their bone and muscle mass, because they don't have that constant gravity.
Yeah.
So your body is really good at adapting. So if you don't need the muscle and bone, your body will start to let it go. And same with the fluid shift, then your body is perceiving that you have too much fluid because it just moved headward, and that's where the receptors are that are looking for fluid balance. So you will see in their first few days, there will be a lot of fluid loss. So they will basically urinate a lot of their volume out. So then they will be low volume to compared to what they would be on Earth.
Okay.
So lots of changes. The immune system is really interesting. So once you're in the stressors of spaceflight and also with this headward fluid shift, some stagnation, so the immune system is not working as well. It's more compromised, and certain viruses that you get in childhood, or maybe people are vaccinated from them sometimes now, but like chicken pox or those kind of viruses, they can get reactivated in space, and then the astronauts can have little skin rashes and those kind of irritations. So all different parts of the body and physiology are impacted, and that's the job of like the human research program at NASA, to study all of these different physiology and come up with countermeasures or different things that can help address these problems. So the exercise devices are one. For the fluid shift, we now have these like pants that have a pump in the bottom, and they put a negative pressure to help bring the fluid down. But they only do that for maybe like 20 minutes a day. They can't do that every moment of the day.
That
So
sounds
lot of
really, really interesting. That's so cool. Like you guys are actually working on something which is like quite amazing. Just hearing about it makes us excited about those things.
So this is Argos, the active response gravity offload system. It's a robotic crane that follows the person around and offloads whatever amount of their weight. So if you're trying to do a lunar simulation, then it will offload 5/6 of the weight, so you can be in 1/6 gravity.
Okay.
So we design EVA simulations here. As you can see in the video, someone walking on the treadmill, doing some geology and other just simulations of what kind of work we will have to do on the moon, so that we can evaluate the spacesuit and understand some of the limitations that we have, and what mobility aids or tools can we provide to make their job easier and more effective.
So I think this is the place where astronaut would feel like, okay, now I'm currently standing on the moon itself. They would experience that exact scenario, right?
Yeah, we try to get as high fidelity simulation as we can. Of course, there's other options as well, like using virtual reality.
Okay.
So we have something called Apache, which is our assessments of physiology and cognition in hybrid reality
Okay.
environment. And so for that, we're putting people in the virtual reality headset, and then they can see the lunar surface, and in this case,
Okay.
the South Pole, where the lighting is very dim and there's long shadows because of the way it's positioned in reference to the sun. And there it's some visual challenges, some navigation challenges. So we're also evaluating using virtual reality sometimes too.
Okay, so this is how exactly you would be seeing the landscape, might be the moon, land, like that particular thing is replicated using this VR. So, like, I don't know whether this is a good question or not. Like, how would they know about the place that they have to go? Is there a compass, or is there someone who is consistently telling them, okay, now you should go to this particular place? Now, how do they find the directions, or they just go the spaceship and they don't go far away?
Absolutely. So in the informatics realm, or like decision support systems, you have, of course, like audio communication most of the time. And on the moon, there's not a big communication delay. On Mars, it will become extremely challenging because there is this communication delay between mission support and Mars. So that will be, up to 30 minutes each way. So you can say, hello, Martian, and then it would not get there until 30 minutes later. So that's not too helpful. But on the moon, we do have more real-time communication. So we'll be able to help with navigation, and the scientists here on Earth who are experts in kind of the geologic history, the craters, all the different features that they want to study on the moon, will have a back room where they're supporting, which samples to choose and how to survey certain areas. So there's a lot of support right now that occurs in real time. But one of our big challenges is moving forward. How can you provide different display strips or heads-up displays that can help with navigation and monitoring and some of the things that the ground support is doing now? We have to slowly get it to the point where the crew members in the spacesuit and maybe the people in the habitat who are not going out that day can provide that support along with a lot of software and other things to augment, not having that real-time communication.
So yeah, so like we as engineering students, like we have a normal college life. We go to the college. Like, how was your college life? Like what was the main focus that you did on some particular things in your college? How was your college life?
Yeah, so for me, I was focused on aerospace engineering in undergrad, and I also was on the athletics team. So I played in the golf team, and so that was a big focus for me as well, to balance playing on the sports team and then also doing the engineering. But it also gave me a lot of social support and a great friend group. And I actually really love that at Embry-Riddle Aeronautical University. It's very international. So I had friends from all over the world. Some of my best friends were from Sweden, Belgium, India, so that's where I met a lot of different people in different cultures and language. And that was probably the most rewarding part of going to a place like that. Was meeting all these close friends. And actually I was able to travel to Delhi for one of my classmates' wedding, who I met in that university. So,
so you have actually visited India. Like, how? What is your first thought that comes to your mind? Like when you hear about India, like you have to go. What's the first thing that clicks to your mind?
I would say probably I think mostly about all of the color, kind of like this, like how bright vibrant everything was. And I really love Indian food. I try to cook some Indian food here too, and there's some favorite restaurants, Nepalese restaurant that I love. But I think for me going there was really eye-opening, just to see kind of different things, even just the roads, how there's not necessarily you have to stay in your own lane. You can it's very dynamic and vibrant. So I loved it.
That's kind of dangerous, I think.
For a whole week. It was pretty fun.
Okay, so what would you recommend to the students, those who are looking forward to join NASA, or they are looking to work as you work in NASA? So what would you recommend for those particular students? How can they do, and how can they actually come to NASA?
Yeah, so one of the things that I participated in when I was a student are different NASA challenges. So they have, a lot of outreach and different kind of university or even grade school challenges. And so you can get a team together and compete in various NASA challenges, and they can fit different, if you're more interested in heads-up displays and informatics, they have a suits challenge for that. If you're interested in designing rockets, there's another launch initiative where you can design some mini rockets. So also outside of NASA challenges, there's the Mars Society and other organizations that do challenges as well. Like Mars Society, they do one where you design a whole Mars mission on paper, at least, and you talk about which rockets you will use and kind of your whole concept of operations, and then you can win some prizes for these challenges as well. I think that's a great way to get introduced to different problems, and also kind of the way NASA works, where there's like starting with your concept review, project concept and safety review, then you go to the preliminary design review, then the next phase of design review, so you can learn about kind of more the project management side of NASA too by going through some of these challenges. And then of course there's ways to become an intern at NASA. That's where I started. Intern.nasa.gov. You can apply for different internships, and that's a good way to get a letter of recommendation for a full-time job eventually. I am personally a contractor for NASA, so I work for KBR as a human performance engineer. So there's lots of contractors and a smaller percentage of actual government employees who are more like the leaders, and then we have lots of contractors in the lab. So you can look for jobs with not just NASA, but also all these companies, and commercial space industry is booming, as you all know. So there's SpaceX and Lockheed's and those kind of companies as well that support NASA these days too. So lots of opportunity for all stages of experience. And like I said, it's not even just the vehicle systems, but working on the habitats, the sanitation. There's so many different aspects that you can focus on depending on your interests.
Okay. So that's really great. So I would like to thank you for giving us your precious time and sharing all things about NASA. So thank you so much, Jocelyn, for joining us for this particular interview, and we wish that you would soon be able to wear the spacesuit and actually experience those things on your own. So thank you, Jocelyn, so much for that.
Thank you so much. I really enjoyed talking with you.
Okay.
Best of luck with coding blocks.